And that's me. Great. Okay, welcome everyone, and thanks a lot for joining me for this talk about creativity. Right. Before I start, let me give you a few words about my employer, Datadog. Datadog is an observability platform allowing you to track logs, metrics, and performance status across your applications and organization. We provide more than 700 integrations, including, of course, Android, but we also have iOS, Flutter, and React Native. Also, Unity is a work in progress. And some of our latest features are Session Replay, which allows you to record and then replay the journey of your users in your application, and Synthetics, allowing you to create UI tests from the browser to be deployed on a device farm. Anyway, my name is Xavier Goucher. I'm a staff engineer at Datadog, but I'm not just that. Actually, I have a lot of things that I do outside of work. Something that most of you probably do is create pet projects on GitHub. But I also dabble in writing sci-fi stories. I like to also create some CG images and generative art. And of course, I play the guitar. Spoiler alert. And so I wanted to use the opportunity to talk about all the things I've learned with all those creative outlets and how it also applies in engineering. And when I tried to talk into that with some coworkers, some of them were like, yeah, but I'm not a creative person. And this is the first mistake that they made, thinking that just because they're in a very logic-oriented field, they are not creative. Actually, just to quote Margaret Hamilton, if you don't know her yet, she's one of the person that helped Neil Armstrong walk on the moon. She said that programming is a creative art where imagination and problem-solving skills come together. And I totally agree with that. So we're going to try to see what creativity is and what the misconceptions we can have about that. The first one, first thing first, if you look into any dictionary, you're going to see something that looks a bit like this, right? And in a very short words, creativity is the ability to create something new and relevant, right? And any variation of those words. So what are the misconceptions that we do have about creativity? Well, the first one is that creativity means that it's for arts. And it often is, but it's not necessarily the case. You have a lot of engineering problems that have a lot of creative solutions. Just to give you a couple of examples, the first one is this number that was created by Greg Walsh and then used by John Carmack in the video game Quake 3 in 1999. Essentially, when you do a video game, you have to do a lot of math operation, including computing the inverse of the square root of a number. And doing this process usually takes a lot of operations, right? You have to do some series of approximation, and it takes a lot of time. And when you have to do this 1,000 times for every single frame, so like millions of times every second, every microsecond you can get is important. And with this number, with this truly magic number and a bitwise operation with a floating point number, you get a very close approximation to the inverse of the square root of that number. I'm not going to go into details yet. You can find all the information on Wikipedia or blog post on YouTube, but it's truly creative and very smart solution. Another one is this thing, and I couldn't track down who was the first person to do it, is a very creative solution to the fizz-buzz problem. You know the fizz-buzz problem. You have to write 100 numbers, and every multiple of 3 you write fizz, every multiple of 5 you write buzz. Well, this is the solution to fizz-buzz. Again, not going to go into detail, but you can use it as an exercise to try to find out why it does work. Another misconception is something that I hinted at first, is that creativity is an innate talent. It's something you're born with, so like, of course you're creative, you're born with it. Well, actually, no. Creativity is a skill, and like every skill, well, it's something that you can practice to improve and make grow. Something similar to that is that creativity is easy, right? Because, oh yeah, you're born with it, so of course it's easy for you. Well, again, it's still a misconception. If I can quote Michelangelo, not the turtle, but the guy that painted the ceiling in Italy, if people knew how hard I had to work to gain my mastery, it would not seem so wonderful at all. And essentially, the essence here is that when you see something that someone made, something creative, you only see the result. You don't see all the hours spent actually making the thing, and you don't see the years of practice to be able to actually do the thing in the first place. Finally, something that some people say that creativity equals originality, which is not often the case, right? So Mark Twain said something like substantially all ideas are secondhand, consciously and unconsciously drawn from a million outside sources. And the idea here is that because we are learning from others, this is going to drive the ideas that we're going to have ourselves. And this is a good way to represent one of the three types of creativity. Because, yeah, there are three kinds of creativity. Well, according to Margaret Bowden, who made a whole paper about it in 2009. But essentially, the first kind of creativity that Mark Twain hinted at is combinatorial. The idea here is similar to playing Lego, right? You take one Lego, you take another one, and you plug them together, and you get something new, right? And so, to give you a more concrete example, let's say we wanted to write a new movie. Well, let's try to combine two existing movies. For instance, Truman Show, right? You have the main character, who's a man. He is inside this fake world, and he doesn't know that it's fake, but it's this very fake world. He's meeting very briefly this woman who he falls in love with, and then she disappears. He tries to find her back, and of course, he starts to understand that something's wrong in this world, that not everything is as it seems, and so eventually he's going to break the barrier of his world. If we combine that with the idea of Ready Player One, you're in a massively multiplayer video game with lots of, pop culture goodies that you can buy inside the world, everything is in virtual reality, you can get something that looks like Free Guy, right? And of course, I'm not saying that this is how they came up with a movie, but that's one way to look at it. You take two things that are completely different, put them together, and you get a new idea. The second kind of creativity is called exploratory, and you can sum it up as thinking inside the box. Okay, I know what the saying says, but we're going to come back to that. Thinking inside the box means that you understand the constraints that are set in what you want to do, right? And you're going to try to explore everything that you can do by staying within those constraints and getting as close as possible to them, but never crossing the limit. This example is called the Eternal Ascent Challenge, and it's made by a 3D artist and YouTuber called Clinton Jones. And he does that like every 6 months. Here he has a 3D asset, 3D scene, where you have a character walking up a set of stairs. And people could download the scene and change it to make their own version. But they had a set of rules, a set of constraints. You can't change the camera, you can't change the pace of the character moving up, you can't change the aspect of the flight of stairs. And so, based on all of this, you have those results. Thousands of people have submitted their own version of it, and you can already see that the results are very different from one another. Everyone tried to have their own versions of the character walking up a flight of stairs. Some are very vivid, some are very dark, but everyone has something very different from the same set of constraints. So that's exploratory creativity for you. The third kind of creativity is called transformational. And transformational is what you actually call thinking outside the box. The idea here is just looking at your constraints and just say, what if? What if the constraint didn't exist? What if we went on the other side of the constraints? And you don't have to go very far from the box to think outside the box. You can just go right there on the other side. This is my favorite example here, because it involved 3 different steps of transformational creativity through years. The first step happened in the 1500s, where an Italian mathematician said, when you square a number, the result is always positive. Like 2 times 2 is 4, and -3 times -3 is 9. But what if we had a number, and when we square it, we get a negative number? And so this mathematician invented the number I, which is used in complex number theory, which then he called mental torture, and I can't really disagree with it. But anyway, 1500s, he invented the complex numbers. And then in the 1970s, you had 3 French mathematicians, Mandelbrot, Julia, and Fatou, who decided to ask a simple question. let's create a series of numbers in the complex plane. And this formula is very simple. It's just square the previous number and add a constant, and then square the previous number and add a constant. It's just a very simple formula. And the question they ask is, what's happening when we push the series to infinity? Some series, based on the first number, some series are going to stay very close to 0. And some series are going to go crazy to infinity very, very fast. And when you plot in black the one that stays close to 0, in white the ones that are going to infinity, you get the Mandelbrot set, which is a very famous image, and some of you might have already seen it. And it all boils down from one very simple equation in this complex number theory. And then you have Melinda Green in 1993, who decided to say, okay, when we are doing this, like this, we have the first number in the series, second number, third number. We can actually see where the numbers in the series are going. So what if we took a black image and just added a tiny bit of brightness every time a number in the series goes through it? And then we do that for all the numbers on the plane. And when you do that, you get this picture in the background, which is called the Buddha-Brot, which has a very cloudy, nebula, space-like vibe to it, which I really love. And it's all boiling down from the very, very simple mathematical equation for the Mandelbrot set. So yeah, those are the 3 kinds of creativity. But wait, how does it work exactly? Like how can you create something, right? Well, before doing that, let's talk about something that we might already know, which is a scientific process. Right? Scientific process, which we've used for centuries. It has a few simple steps. First, you are asking yourself a question, right? I have a question about physics or biology or mathematics or whatever. And from that, you're going to do some research to see what other academics or universities have done around this. You're going to then form an hypothesis, a theory about the domain, and then you're going to design a procedure where you're going to say, okay, let's find a way to prove or disprove the theory. And at the end, you're doing the experiment. And then, of course, you're doing a loop, so you're going to come back with the results, publish it, do another question, and so on. And it's very similar to what we do as engineers, especially as Android engineers. Because the approach is like we have a problem. We want to, let's say, I don't know, write an application that allows people to communicate with one another from very far. Well, first, with the problem, you're going to do some research to see what other applications exist, what libraries exist, what protocols exist, and all that. You're going to, of course, set a list of requirements. Is it just text, or do we use emojis, or GIFs, or GIFs, videos, audio, 3D avatars, maybe? And from that, you're going to have a path of design where you're going to do RFCs and ADRs and all of that and drive the architecture of the actual Android applications. And like, do we use Compose? Do we use KMP? You're going to also do some design on the protocol. Do we use GraphQL or something else? And at the end, you do the implementation. Feel familiar, right? OK. Now let's talk about the creative process. Well, it's not the creative process, it's just a creative process, but it's one that's been theorized by Graham Wallace in the 1920s and that a lot of people are using. The creative process, as it goes, is something like this. First, you have the preparation, of course, and then incubation, illumination, evaluation, and elaboration. Easy, right? OK, let's take a step. First, you have preparation, and preparation is essentially brainstorming and trying to find what you want to do. For instance, maybe you say, OK, I want to make an application where people can chat as 3D avatars. Or maybe you're saying, oh, I'm going to write a song that I'm going to play on the stage at Android Makers, right? Then you're going to do research, of course. You're going to see if other applications like this exist or if some other engineer tried to play guitar in an engineering conference. Spoiler alert, there is. And then you're going to have the Eureka moment. Eureka moment is kind of like the House MD show, right? The doctor, very smart, but kind of an asshole as well. And every time in every episode of the show, you're going to have House that is having a discussion with his best friend, Wilson. And Wilson is going to say something, just random. He's going to say the word umbrella. And from that word, house is going to stop, listening to the conversation. It's just going to say, oh, yeah, this is what's wrong with my patient. And so it's going to storm off, just forget the conversation, just storm inside the OR and save the day. So that's the eureka moment. Eureka moment is that you're going to have something connected in your brain, and you're going to have the core skeleton of the idea of what you're going to do. Well, then once you have this, of course, you're going to have to do some design to make sure that, just from the skeleton, how you're going to, flesh it out. What are all the parts that are going to be around it? And once you have your design, you go through implementation. And now when you look at all of those, they actually have a very similar structure, right? You always start with your initial question. You're going to do some research, of course. You're going to know exactly what you're going to be looking at. Then you're going to have the design and the implementation. So we know how the creative process works. We know how the creative process works, but how do we get there? How can we boost our creativity to get to this eureka moment? Because that's the key part, right? Well, there are quite a few ways to do this, and I can't list them all, of course, but we're going to try to go through it. The first one is called learn the rules, break the rules. And if I can make a parallel with music, for instance, for centuries we had those very set in stone rules about music theory, right? Where you can only play this note after this one, or you can only play those chords because these other ones are dissonant, or you can only use those scales, and they have very weird names like Mixolydian or Lydian or Aeolian that only a few people on the planet can understand. And then in the beginning of the 19th century, you had a few things that happened. One of them is some composers were like, okay, what if we didn't use one of those scales and we just used all the notes? And you got the atonal music genre that, like Schoenberg, where you have all the notes and you just remove the rules. Another thing that happened in the 20th century is some people said, oh yeah, I know this chord is supposed to be dissonant, but I'm going to play it anyway. And then you get jazz. And it still sounds good. So how do you apply that to engineering, right? Well, here the idea is to understand all the best practices that you've been taught, like TDD, our solid principles and all of that, right? You've all applied them, I hope. But have you ever wondered, why do we use it? Why were they invented in the first place? What do they bring to the table? Well, that's the thing. Learn the rules and learn why we have those rules, so that one day you can be, oh, actually we're not going to use the Liskov principle because it doesn't apply here, and we can still get benefits from other principles, and you can get away with it. Right? So learn the rules, and of course you're in the right place here to learn all of the rules, because you're going to have lots of talks about amazing topics. The other thing is, and it goes with this, is mastering your tools. Like, the idea here is that you don't want your tools, like Android Studio or Git or Kotlin or anything, be an obstacle to your creativity. You don't want to be like in the flow trying to write your algorithm, and then you're like, oh wait, how do I do this in Kotlin? Or is there an option in Android Studio that lets me do something like that? So again, you're in the right place. Actually, just in half an hour, you're going to have Ben Kittle, who's going to do a talk about Git internals. So stay in the room. I'm pretty sure it's going to be great. So yeah, master the tools, learn all that you can, even about the OS, like the specifics of the shell system, or all the options that you have in your OS to make sure that your laptop is not an obstacle to your creativity. Then you want, of course, to collaborate with others. The main reason why is that other people are going to have a different perspective, a different point of view, and a different experience. And you can learn from their experience without having to live their experience. So you can go with a coworker and say, oh, actually, I was thinking of doing this thing or writing this library. And the coworker is going to say, oh, yeah, that's a good idea. Have you thought about this specific edge case that might happen? Oh, yeah, no, I didn't think of that, right? Or maybe the coworker is going to say, oh, actually, a few years ago, I did actually try to make a 3D avatar chat application, and we used this library. It didn't work so right, so you might want to avoid it. So talking with others and bouncing ideas with others can, help you better understand if your ideas are good, but also how you can improve on them and how you can do the design part to flesh out, get the details around it. Then you want to be curious. And the main thing here is that you want to feed your brain, right? It's part of those research parts. You don't have to do the research just after knowing what you want to do. You can do the research beforehand, right? Because the thing is that the eureka moment is going to connect to things and not necessarily the one thing that you're studying right now, but it could be something that you heard 10 years ago, right? So feeding your brain is a great way to learn about new stuff, right? Be curious. And it can be anything. It can be, trying to learn a different language, because some language have a different structure from English or French or German, and they have like it requires you to think at what you want to say in a different way, right? Or try to learn a new skill, or try to do a new sport, or anything. Just to give you one example, a few years ago I was working at Deezer, and I was working on the music player. Not the UI of the player, but the actual, player, because I can't do UI for the life of me. And a few months before, I started to look at an article about how a jukebox works. The big boxes that play vinyl records. Old thing. And yeah, I'm old. Well, I was curious, and I looked into it, and I learned how, the mechanics go to, say, when you push a button, it's going to actually go and fetch, the actual vinyl record and put it on the player, and then the player is going to play it, and when the song is done, it's going to grab it back and put it back in its place. And at some point, when I was doing this work on the Deezer app, I was like, oh, but actually it's something very similar. I have to fetch some music, not physically, but from, the cloud, and then play it, and then discard it. And so the architecture and the design of an actual physical object from 50 years ago actually drove the architecture that I use in the library, which, by the way, I called Jukebox, and is still in use in the Deezer app today. So be curious, because you don't know where your next idea is going to come from. So we talked about feeding your brain. We also want to keep the brain healthy. Right? So you want to, I'm not going to go back into details about the Pomodoro techniques and so on. It's like a great idea. You want to take breaks often from your work to keep your brain, rested. But also, there are some things that are proved to boost creativity, like being in nature or doing things that bring you joy, right? Shocker. So if you can, of course, try to regularly take a walk in the forest or in a park or on the beach, spend time with your friends or with your kids or with your significant other, do board games or have a match of soccer or football or other things. But just try to do things that make you happy. Try to get away from your screen and just take a moment in nature to put your brain at rest. Something that goes with this is daydreaming, which is something it feels like we don't do that anymore. But daydreaming is a great way to find new ideas. Because daydreaming is essentially your body doing either nothing or something very mechanical, and your brain just saying, oh, okay, like it's using like just 1% of CPU, so I'm going to do something else. Something that works great for me is doing the dishes, right? The thread that's dealing with the plates and the sponge and all of that is automated, and then I have all the other threads in my brain that's just wandering into sci-fi stories, music, problem in Kotlin or stuff. And so yeah, it's a great way to daydream. And of course, what goes with it is taking a break from your screens, right? Not literally breaking your screens like it, just turn them off, right? Even for half an hour every day, because our screens are screaming from our attention, right? We have all the streaming apps, we have all the social media apps, Instagram and TikTok and YouTube and all of that screaming for our attention and so we don't get away from the screens, meaning that we don't get ourselves in a situation where we can get bored and daydream, right? Plus, the problem with those infinite doom scrolling applications is that you're going to be faced with lots and lots and lots of people that are showing off what they did, people saying, hey, I wrote this library, and oh, I made this picture, or oh, I made this. And that's the same thing that we had with Michelangelo earlier. You only see the results. You don't see the amount of work that had to be done just to get to that result. You just see one people after the next showing the results, and you're like, I'm never going to be able to do that. Actually, something that I really like to oppose that is watching devlog in YouTube. Devlogs, especially video game devlogs, because it's very entertaining. Video games devlog, you can have a video that's half an hour of an engineer trying to say, oh, this is how I fixed the way my character walks in the game. And it's going to be half an hour just on this, where he's going to start and say, well, the other day I was playing the game and I was noticing that there were some errors and glitches in the way the character walks. And so then I looked into it and I pulled this algorithm to improve the way the character follow the shape of the terrain and to make sure that the hand doesn't slide and so on. It's half an hour of technical algorithm about how the character walks. And this is great because, first of all, you're going to learn algorithm you never knew you didn't know. But also, you're going to realize that everything takes a lot of time. And so seeing someone struggle and spending months on just fixing this tiny thing is going to make you, more at ease at the time it takes you to actually do your own pet projects. Of course, you need to be ready for failures, right? Being creative means often taking risks. And so taking a risk is also taking the risk to fail. And sometimes people don't really like failure. The thing is that failure is the best way to learn. When you're failing, you're going to learn a lot more about the things that you didn't know because you had the wrong assumptions or you didn't account for some specific edge cases. And when you succeed, well, you succeed, you don't really have feedback. It works, but you don't know if it's going to work all the time. We do learn more about our errors than our successes. So being in the mindset where you say, okay, I may fail, but if I fail, first, I'm going to fix it, and then I'm going to learn from it. So how does it work in practice? Right? How can you actually bring more creativity in your work? So first of all, the saying, practice makes better. You never get perfect, right? But practicing makes you better at everything you practice at. So, of course, doing hackathon is a great way because you can, try new things, try this new language. You're going to say, oh, I want to try Rust. You can try Rust in the hackathon. At Datadog, we have something that we call Innovation Week, where twice a year we have 1 week where we can just, we stop working on the Jira tickets. We're just working on an idea. Right? And it can be an idea that's going to be included in that could be included in the product. So, oh yeah, we're going to add this feature in the project. Or it could be writing a tool that's going to help the engineers to, reduce the time we wait on CI, or reduce the friction with doing things that are cross-platform. And basically, it's 1 week where you are allowed to do whatever you want, as long as it's within the bounds of the area we are doing in the team. But it's great to try new things and to possibly fail safely. And of course, you have side projects. Almost everyone is going to have this side project on GitHub. And this is also a great way to learn, because side projects, you can try to reinvent the wheel. Right? You can say, oh, okay, I don't really know how compression works, so I'm going to write my own gzip library. Or you're going to say, oh, I want to understand how fonts work, so I'm going to write my own font renderer in Compose. Or it could be anything else. But the good thing is that because you're going to learn from things that are already been around for years, and possibly with existing open source code, you can actually really learn things because, like, for instance, just the compression thing, I started learning how to write an early compression algorithm for images and learn how it works, and mind blown. Another thing to do is, when you have a specific problem you want to be creative in, is to define the problem boundaries, and like all of them. You need to write all the constraints, because writing the constraints can help you if you want to do the thinking inside the box or thinking outside the box approaches. But also you want to list all of the requirements, because some of the requirements can spring an idea and say, oh, we have these requirements, and maybe we can twist it a bit and do something creative there. And of course, you need to list all the opportunities, right? Not just why do I want to do this project, but also what this project could apply that's not the original goal, right? Which kind of also is a good segue with different ways to generate ideas. The first one is, of course, brainstorming, which is essentially writing on Post-it notes or on a whiteboard or a notepad or anything. Just write the ideas with no filters, nothing, just write anything that passes through your mind for half an hour. Right? You write all the ideas, even the crazy ones, and then you come back to the ideas and you sort and filter and analyze them. But the first step is always to brainstorm, is to say, I'm going to write down everything that passed through my mind without any filter, without any judgment, and then we come back to it. And then you have two other methods that are rarely known, which are the Scamper and the MacGyver method. The Scamper method, it's really an acronym, which is one way to look at something that you already have, so an app that already exists, and trying to find ways to improve it, right? And there are, 1, 2, 3, 4, 5, 7 ways to improve it. First one is substitute. You change something for something else. You replace a part, a component, something in the UI, in the UX, or in the code to improve it. C is combine. How can you improve by mixing your app with something else that exists? A is for adapt. So can we adapt this project to new platforms, right? Can we adapt this project for a watch or a tablet or a car or something else, a TV? M is for modify. It's just, okay, can we do something different? Like let's just change the way this feature works. P is put to other use. Okay, I have an application that lets me chat as 3D avatars with my friends. Can I use it for support, for instance? And then you have eliminate, which is like exterminate. Take something that's not used in the app and just remove it to make it faster. And of course, rearrange is just, can we shift things around? So keep everything the same, but just move things around, rearrange them to make it more efficient. Like maybe the login process has one step that you should move later downwards because it's going to remove the friction. Or for the checkout, you're going to make one step earlier to ensure that people have their credit card ready. Then you have the MacGyver method. And the MacGyver method goes in 3 different steps. First step is write a question. What are you trying to be creative about? Then you do an incubation activity. And this is essentially what I was talking about in the daydream slide, right? It's trying to do something where your hands are going to be occupied, but your brain is going to be free, right? And not necessarily, and of course, you don't have to try to think about the question, but try to think about something else, right? And at the end, you write the answer. It's not necessarily always the best answer from the first time, but if you repeat it, you're going to bring new ideas that you didn't even think of beforehand. So why should we care, right? Especially now in 2024, why do we care about creativity? Well, I'm pretty sure you've all noticed that there is something called artificial intelligence that we've been talking around a lot nowadays, which kind of goes across, is human creativity really relevant? And then every time we have news where we hear about Gemini or GitHub Copilot or Devin, ChatGPT, Tab9, or the Code Whisperer, I have a coworker that's going to say, oh, we're out of a job. No, we're not. We're not out of a job. Because as great as those tools are, they still have some major flaws. So first of all, how does it work? Most of them, especially if you look at the language models that are used in Copilot and so on, are trained to find what's the statistically best next word. And the way it works, I'm not going to go into detail, but you have an input. It's going to go through a whole lot of math operation and give you an output, right? And there are some great videos that explain how it works actually, but essentially, it's really just statistics. So the issue is that they don't have any intent, right? They don't wake up one day. You don't have like Midjourney or DALL-E, who make images, waking up one day and say, oh, you know what? I'm going to paint a picture of a zebra playing guitar in front of a castle. I had to type that in. So, great picture, by the way. It's going to be my next avatar. No AI is going to wake up one day and say, oh, I'm going to do this, or I'm going to do that, right? You have to have human creativity from the start saying, oh, I want to have the zebra playing the guitar. Also, they don't have any sense of value, because it's all statistical probability, right? The AI is not going to know if the result is exactly what you wanted, or if it's even relevant, right? I don't know what's happening to this zebra, but I'm pretty sure it needs to find a vet right now. And of course, they don't have any semantics, right? Same prompt for all 3 images, by the way, and I'm still trying to find the zebra in this image. They don't know what a zebra is, they don't know what a gear is, they don't know what a castle is, they just know that if you type those words, those pixels are the most probabilistically relevant, but not necessarily the best. So AI is a great tool, and it can do great things. I've been trying copilots for a week, and I was like, sometimes it did some truly great things, and sometimes it was like, okay, barely okay. Sometimes it was really, really not good. But it needs to be driven by human creativity. We need to be at the origin of it and say, okay, this is what I want to do, and then help me write it faster, or help me do it faster. So, we're getting to our takeaways. The first is going to be a quote by Erica Heide, who made a lot of talks and blog posts about creativity, who said that programming is art built on top of logic. And essentially, you can see this like programming is creating something out of nothing. We have a blank page, we have a blank project, and we're trying to make writing lines, we're trying to make the project emerge out of nothingness. It is art, but it's built on top of logic. So even if you apply all the creativity principles that you can think of, and the one that I didn't mention even, you still need to have your engineering mind make sure that the result is sound. So even if you're trying to be creative and break the rules and all that, at the end, you can still make sure that it follows some best practices, that you still have tests, and that the performance are great. The other takeaway is going to be on the guitar. Perfect. Okay, 2, 3. In the chaos of Kotlin lines, suspend functions tangle like vines. I need to come up with a plan to publish an app that will shine. I need to overcome so much folded devices I can't touch, deprecation of APIs, legacy code I don't recognize. 1, gotta prepare my mind. 2, do research for a while. And 3, wait for a little tick until the cogs in my brain can all click. Brainstorm the ideas, put together all the pieces. 5, that's it, it will be the best. Just have to write another test. I read the book that Chet has done. I booked ticket for DroidCon. Of course, I watched all of the talks and tried thinking outside the box. I learned about Git hooks and hoops that back compose internal loops, Android Studio's latest tricks, and Unix systems obscure tips. And 1, gotta prepare my mind. 2, do research for a while. And 3, wait for a little tick until the cogs in my brain can all click. 4, brainstorm the ideas, put together all the pieces. 5, that's it, it will be the best. Just have to write another test. I learned to knit, to paint and bake, although you shouldn't try that cake. I learned Python and sign language just to see if I could manage. I turned my phone off for a day, which turned out to be quite okay. Wandered alone in the forest, played card with my daughter and lost. And 1, gotta prepare my mind. 2, research for a while. And 3, wait for a little tick until the cogs in my brain can all click. 4, brainstorm the ideas, put together all the pieces. 5, that's it, we'll be the best, just have to write another test. Gotta prepare my mind. 2, do research for a while. And 3, wait for a little tick until the cogs in my brain can all click. 4, brainstorm the ideas, put together all the pieces. 5, that's it, we'll be the best, just have to write another test. Thanks a lot, everyone.